lesson number 1, which is linear relationships, aka defining a function. So our standard basically talks about the fact that we need to understand that a function from one set called the domain to another set called the range assigns each element of one domain to exactly one element of the range. So basically we're going to talk about what defines a function and what makes something not a function. Now if you guys want your participation for today, make sure your phone is away during my notes and during the activity. So a plane is divided into, how many regions are there in this plane right here? 4 regions used for graphing. Okay, and this helps us locate things on the coordinate plane, the 4 quadrants. We call these 4 quadrants. And the 4 quadrants, we're asked to label the origin. So the origin is this middle point right here. We call this the origin of the graph. Okay, and the origin is known as the coordinate 0, 0. Now the quadrants go a little bit in an order that you probably wouldn't expect. So this is your first quadrant. This is your second quadrant. This is your third quadrant, and this is your fourth quadrant. So those are your 4 quadrants of your graph. And then lastly, x and y axis. Which axis is this one that goes vertically?
Y.
Good. This is the y-axis. And the one that goes horizontally is the?
X.
Good, the x-axis. Very good. All right. Any questions so far? All right. Moving on then. So a function is a relation where every element of the domain is paired with exactly one element of the range. Every x has only one y. Moving on. So every x value has only one y value. So think about a soda machine. The x values are your buttons, and the y values are what comes out of the machine. So obviously, if you have a button, you're not going to get, it can't go to 2 different sodas. You can have a button that goes Sprite or Coke. You're not going to want to push it if you don't know what you're going to get, right? So that's how a function works. So now we're going to talk about representation of functions. So functions can be represented several different ways. These are the main 4 types of ways. They can be represented as ordered pairs. A function, this is called a mapping, a graph, or a table. Okay, so we can label that if you want. This is ordered pairs, this is mapping, this is graphing, or this is a table. So let's talk about what makes something a function and not a function. So not too worried about you guys understanding the wording of it, just understanding the difference and how you can identify when it's a function, when it's not. So I zoomed in. So from here, we're going to identify the sides on, or the ones on the left are functions, and the ones on the right are not functions. So let's talk about the difference. So I know this one is a function because I go through the x values, and you notice there are no repeating x values. Okay? Now that doesn't necessarily, that always means it's a function, but you can have repeating values that will be a function, and we'll talk about that in a little bit. But over here, as you can see, do I have any repeating x values on the right? Repeating x values on the right. You can look on your sheet too if you can't see it. Yeah, which ones are repeating? The 3. See how these are repeating? And see how they're associated with 2 different y values. So this makes it not a function. That's why it's not a function. Okay? Now over here, as you can see, these are the x values and these are the y values. Okay? See how each x value only goes to one y value? So that means it's a function. Now over here, what's the problem? Why is this not a function?
Too many is in one.
Good, you can't have one x value going to 2 different y values or more than one y value. So this is what makes this not a function.
Were you talking about earlier that if
I will show you an example like that.
Like if it would both be like 3, 8.
There are definitely times where if this were 3, 8 and 3, 8, this would still be a function. It's just if they have different y values. So then down here, this is a function because it passes what we call the vertical line test. Okay? I can draw a vertical line and it only hits 1 point on that line. I can draw a vertical line anywhere on the graph and it's only going to hit 1 point. Now over here, is that the case? No. What happens when I draw a vertical line right here? It hits more than 1 point, so that is not, that's what makes it not a function. Make sense? Now lastly, we'll look at the table. So the table is just a representation. You can see the table written horizontally or vertically. So the first thing you always want to check, are there any repeating x values? Not in this one? No, we don't have to worry if there's no repeating x values. Over here, are there repeating x values?
Yes.
All of them. And they go to different y values, don't they? So this is not a function for that reason. Okay? If you're repeating, you always look for repeating x values, and then you look, do they go to different or the same y values? If they go to different y values, it's not a function. If they go to the same y value, it still would be a function. Pretty easy. Now the last thing we're going to talk about is we're just going to go through and do these problems together. So, as you guys can see here.
Number 3 is not a function.
Correct, it's not. Good. This one is not a function, and that's because we have repeating numbers with different y values. What about number 1? Is it a function?
Yes.
What about 2?
Yes.
What about 4?
No.
No. What about 5?
No.
No. And what about 6?
No.
No. Because you can't have x values going to two different y values. Now I do want to quickly just show you something. You don't have to draw this, but this one I think throws students off sometimes, so I do want to show you. So say we have like 1, 2, 3, and then we have like 4, 5 over here. And we have 1 going to 4, we have 2 going to 4, and we have 3 going to 5.
It only matters if it only matters if x is repeating or not, right?
Yes. So the idea here is that it's okay to have two x values go to the same y value, but one x value can't go to two different y values. So this is okay. It's just the x has to be going to its own. There can only be one arrow coming out, but there can be the arrow going in the same direction though. You can go to the same destination, okay, but you can't go to two destinations at the same time. Does that make sense? Okay. So we're gonna stop the notes and we're gonna play the game.
Okay.